Can sea anemones regrow their heads? So today, we're going to be talking about whether sea anemones can regrow their heads if they get ripped off. And just as a quick disclaimer before we get into it, I will be referring to the head region of the sea anemone as the oral disc, because technically speaking, they don't have heads. It's more like a mouth surrounded by a disc of unattached stinging cells that are used for capturing prey. But yeah, so as usual, I'll be getting straight to the point and answering the question with a question. Do sea anemones have a strong regenerative ability? The answer is yes. Sea anemones belong to the group of animals called Cnidaria, which includes jellyfish. And these guys are famous for having the ability to completely regenerate their bodies given enough time. Even if you were to cut one up into multiple pieces, most of them would be able to regrow their entire bodies from the remaining bits. So it seems likely that if you were to separate the head of a sea anemone from its body, then the body could probably regrow its head, right? Well, not exactly. It turns out that it actually depends on the species of the sea anemone as well as the size and overall health of the individual. Some species like Metridium senile are capable of regenerating their heads from any part of their body, while other species require a larger amount of tissue in order to do so. In some cases, all that's needed is a small portion of the uninjured petal disc, which is the part of the anemone that attaches it to surfaces. While in others, a larger section of the column, which is the stalk-like structure connecting the oral disc and petal disc, is required for head regeneration. For example, in the species Edwardsiella lineata, petal fragments smaller than 2 millimeters in diameter were unable to regenerate a head, while those greater than 4 millimeters in diameter were able to do so at a rate of 100%. Those around 2 to 4 millimeters took about 30 days to regrow a new head. There are also instances where a separated head has been able to develop into a new individual, but this appears to be less common and might require different conditions. In one study, researchers found that a separated head could develop into a new anemone if it had a certain amount of undamaged petal tissue along with the head region. However, when only the head region was present without any petal tissue, it never developed into a new animal. And the same thing happened if the separated head was injured. So it seems like the presence of a small amount of undamaged petal tissue along with the head region might be necessary for the development of a new anemone. But again, this might depend on the species of sea anemone. Overall, while many sea anemones are capable of regenerating their heads, the exact requirements for doing so vary depending on the species. So it's difficult to say exactly what's needed in order for this to happen. However, we do know that some sea anemones can completely regenerate their heads under the right conditions. So what are the conditions that allow sea anemones to regrow their heads? Basically, it comes down to three main things: clean water, optimal temperature, salinity and pH levels, as well as no infection or excessive damage to vital tissues. Most studies on sea anemone regeneration have been done in clean, filtered seawater at room temperature, usually somewhere between 18 degrees Celsius and 24 degrees Celsius, or 64 degrees Fahrenheit to 75 degrees Fahrenheit. In terms of salinity, most sea anemones can tolerate a range of salinities, but the optimal range for regeneration might be slightly higher than normal. For example, in one study on the sea anemone Nematostella vectensis, the highest rate of head regeneration occurred at salinities between 30 and 35 parts per thousand. However, this species was still able to regenerate its head at salinities as low as 10 parts per thousand, which is much lower than normal ocean salinity. So it seems like sea anemones can tolerate a range of salinities, but the optimal salinity for head regeneration might be around 30 to 35 parts per thousand. pH is another important factor for sea anemone regeneration. Most sea anemones prefer a slightly basic to neutral pH, and very low or very high pH levels can be stressful or even lethal to them. One study found that Nematostella vectensis had the highest rates of head regeneration at pH levels between 7 and 8.5. However, it was still able to regenerate its head at pH levels as low as 5.5, which is quite acidic. So it seems like sea anemones can tolerate a range of pH levels, but the optimal pH for head regeneration might be around 7 to 8.5. In terms of the conditions on Earth, there aren't really any places that naturally have pH levels that are too high. The highest pH level that occurs naturally on Earth is around 9. However, there are some places with very low pH levels, such as volcanic areas and deep ocean trenches. So it seems like sea anemones are more limited by pH levels on the lower side rather than the upper side. Optimal temperature is also important for sea anemone regeneration. Most sea anemones prefer a range of temperatures between 15 degrees Celsius and 25 degrees Celsius, or 59 degrees Fahrenheit to 77 degrees Fahrenheit. Outside of this range, their metabolism slows down and they might become stressed. One study found that Nematostella vectensis had the highest rate of head regeneration at 20 degrees Celsius. However, it was still able to regenerate its head at temperatures as low as 10 degrees Celsius and as high as 25 degrees Celsius. So it seems like sea anemones can tolerate a range of temperatures, but the optimal temperature for head regeneration might be around 20 degrees Celsius or 68 degrees Fahrenheit. Finally, it's important that the water is clean and free of debris in order for sea anemones to regenerate their heads. Dirty or stagnant water can lead to the buildup of harmful bacteria and other microorganisms, which can cause infections and hinder the regeneration process. It's also important that there's no excessive damage to vital tissues such as the mouth or petal disc. If these structures are damaged, it can make it difficult for the anemone to eat or attach to surfaces, which can negatively impact the regeneration process. So to sum everything up, in order for a sea anemone to successfully regrow its head, it needs to be in clean, unpolluted water with optimal temperature, salinity, and pH levels. Additionally, it needs to have a sufficient amount of undamaged tissue, specifically a portion of the uninjured petal disc. While some species can regrow their heads from any part of their body, others need a larger section of the column or petal disc in order to do so. So overall, it's not possible to give a simple yes or no answer to the question of whether sea anemones can regrow their heads if they get ripped off. It really depends on the species of sea anemone as well as the size and overall health of the individual. However, we do know that many sea anemones are capable of regenerating their heads if they get ripped off under the right conditions. If you enjoyed learning about whether sea anemones can regrow their heads, then be sure to stay tuned for more of my videos in the future. Thank you for watching and have a good one.